Harvard astrophysicist Avi Loeb has been one of the most vocal scientists suggesting that some interstellar objects passing through our solar system might not be entirely natural. His views became widely discussed back in 2017 when he proposed that the object known as Oumuamua could have been a form of alien technology rather than just a comet or asteroid. That background has meant that when new interstellar objects are spotted, his name and perspective tend to come up quickly. One such case is an object that has been given the working name Atlas. It first came into view on July 1st and was initially logged as dim and faint, barely distinguishable from the background stars. At first, there was little reason to think anything unusual was happening. Objects like this are cataloged all the time, and the working assumption was that this was just another comet-like body making a long, harmless pass through our solar system. For months, most astronomers assumed Atlas would perform a relatively unremarkable flyby. Early calculations suggested that its closest approach would take it past Mars without any collision risk. At the time, it was called an interloper, a visitor from another system, yes, but not one that posed any threat. That calm interpretation didn't last. As more data came in, the picture began to change in ways that puzzled experts. Teams at Harvard, NASA's Jet Propulsion Laboratory, and independent research groups across the globe started running refined orbital models. These updated trajectories suggested something unusual. Atlas was not behaving like a simple chunk of ice and rock. Its path was too precise and its motion too consistent. Natural comets tend to wobble slightly as gases escape from their surfaces, producing small but noticeable changes in speed and direction. In contrast, Atlas seemed to be maintaining an unnaturally smooth trajectory, as though under guidance. When scientists examined its speed, the numbers became even more striking. Atlas was traveling at nearly 87 kilometers per second relative to the Sun. To put that in context, that is faster than anything human technology has tracked coming from outside our solar system. At that velocity, it would take less than 80 minutes to cross the distance between the Earth and the Moon. That's a staggering thought. In the time it takes most people to eat lunch or watch a film, this object would have already covered hundreds of thousands of kilometers. The forces acting on it are, of course, immense. The gravity of the Sun, Jupiter, and Mars all tug at its path, shifting it by tiny amounts every second. These may be just micrometer-scale changes in velocity, but when extended across millions of kilometers, they add up to major differences in trajectory. That means predicting Atlas's path has been a constantly moving target. The Mars Reconnaissance Orbiter, a satellite that has been circling Mars since 2006, has also been monitoring Atlas. Its instruments picked up changes that made the story even stranger. The cloud of gas and dust surrounding the object, known as its coma, doubled in brightness between July and August. This is not unheard of in comets, but the rate of change was faster than usual. Ultraviolet spikes and bursts of high-energy radiation were also recorded, and the amount of carbon dioxide gas being released was measured at levels far higher than what is normally seen in solar system comets. Normally, as a comet approaches the Sun, its activity increases for a while, but then begins to stabilize. Atlas, however, showed the opposite pattern. Instead of leveling off, it began to accelerate, as if under additional influence. The word course-correcting has been used by some scientists, comparing it to the way guided missiles adjust their paths. This kind of analogy is unusual in academic astronomy, but it reflects just how puzzling the data appeared. New trajectory calculations published in recent months narrowed down Atlas's approach to Mars. Its closest pass is now predicted to be just 1.95 million kilometers on the 26th of September 2025. In cosmic terms, that's extremely close. what planetary astronomers sometimes call a hair's breadth. At that distance, Mars's gravity could have a serious effect. It might bend the object's path, capture it temporarily, or even draw it into a closer encounter. The risk becomes more apparent when you consider how small a push is needed to change the outcome. Just an additional 10 kilometers per second of velocity could make the difference between a near miss and a direct impact with Mars just a few weeks later. For comparison, that amount of momentum is less than what a launch vehicle like SpaceX's Starship uses to leave Earth's atmosphere. On a cosmic scale, it is a modest nudge, but for an object the size of Atlas, it could completely rewrite its fate. Astronomers have been watching the tail of Atlas closely because outgassing can naturally create small shifts in motion. Gases venting from its surface act like miniature thrusters, producing gentle pushes. But the data so far suggest these emissions are not behaving in a random or chaotic way, as they typically do with comets. Instead, the activity appears to be unusually rhythmic. Spectroscopic observations made from the Gemini South telescope in Chile revealed a surprising detail. Atlas was releasing pulses of gas at regular intervals, roughly every 17 minutes. These weren't occasional or scattered events, but repeated patterns, sustained over several days at a time. That kind of behavior is not consistent with natural cometary activity. Typically, jets form when sunlight strikes fresh ice, and they flare unpredictably as the comet rotates. Regular timing suggests something more controlled. Although most astronomers are cautious about using words like engineered, the pattern has led to speculation. The timing looks very similar to the way spacecraft fire thrusters in bursts to adjust their orientation or trajectory. If this interpretation holds, Atlas may not just be drifting, it may be actively steering. The potential consequences of that steering have been mapped out in predictive models. If Atlas continues to make these small but regular adjustments, then by the 19th of September 2025, just a week before its closest approach, it could maneuver itself to within 50 kilometers of Mars. That is closer than some of the planet's own moons. At such proximity, even one powerful outburst of gas could push it into a collision course. At this stage, the official position from space agencies remains measured. Both NASA and the European Space Agency stress that no confirmed impact is currently predicted, and they highlight the uncertainties involved in projecting orbital paths over long timescales. Nonetheless, the increasing evidence of unusual behavior has shifted the tone from casual observation to heightened monitoring. For planetary astronomers, Atlas represents both a challenge and an opportunity. The challenge lies in explaining its motion with the physics of known natural processes. The opportunity lies in the fact that it is providing a live case study of interstellar material interacting with the solar system. Interstellar objects are rare, and each one adds to our understanding of how matter moves between stars. Still, the language being used in private discussions is more urgent than the calm statements issued publicly. The possibility of a collision with Mars, however small, cannot be ignored, especially as new data continues to tighten the margins. Researchers are now working on multiple scenarios, from a harmless pass to a direct impact, and everything in between. The coming months will be crucial. More ground-based telescopes will be aimed at Atlas, and spacecraft around Mars will continue to gather data. Every new set of numbers reshapes the predictions. The story of Atlas, once thought to be just a faint passing dot of light, has now become one of the most closely watched astronomical events of the decade. Models suggest that if this pulsing continues, Atlas will steadily adjust its path towards Mars. By the 19th of September 2025, just days before its closest approach, it could place itself within 50 kilometers of the planet. To put that in perspective, that is closer than the orbit of Deimos, Mars's smaller outer moon. At such a distance, even a single strong pulse of gas could provide the nudge needed to change its trajectory from a near miss into a direct collision. The prospect of a collision has been studied carefully. Estimates put Atlas's mass at around 10 billion tons, with a metallic-rich core possibly 400 meters across. An impact at speeds near 57 kilometers per second would release the energy of roughly 2 million megatons of TNT. That is thousands of times greater than the largest nuclear device ever tested on Earth. The resulting crater could measure more than 60 kilometers wide and around 5 kilometers deep, throwing massive amounts of debris into the atmosphere and into orbit around Mars. Some fragments might even escape the planet's gravity and drift into interplanetary space. The danger is not just theoretical. Mars today is home to a fleet of spacecraft, rovers, and orbiters. The Perseverance rover is still conducting science in Jezero Crater. The Mars Reconnaissance Orbiter, after almost 2 decades in orbit, remains a vital communications relay for other missions. Other probes, such as MAVEN, Mars Odyssey, and the European Space Agency's Trace Gas Orbiter, are still active. All of these assets could be damaged or destroyed if Atlas were to strike. Decades of investment and invaluable science could be lost in a matter of seconds. It is partly for this reason that multiple space agencies have increased their monitoring efforts. Although official public statements are calm and measured, leaked documents suggest more urgent work is happening behind the scenes. One report claims that NASA is already using the Mars Reconnaissance Orbiter as a forward radar, bouncing signals off Atlas to measure its core more precisely. Goldstone, part of NASA's Deep Space Network in California, has also redirected its powerful radio antennas to probe the object. According to some insiders, the echoes being received are sharp and metallic, unlike the softer signatures typically reflected from dusty or icy bodies. While these claims have not yet been formally published in peer-reviewed journals, they add to the sense that Atlas may not be made of entirely natural materials. One hypothesis under discussion is that Atlas might conceal an artificial interior wrapped in a shell of ice and dust, allowing it to mimic the outward appearance of a comet. If so, then the regular gas pulses could be intentional, serving as a propulsion system. Avi Loeb and some of his colleagues have even suggested it could be a directed messenger, a probe using its exhaust gases in a carefully controlled way to steer. This idea gained traction when the European Space Agency's Mars Express orbiter photographed a series of unusual points of light above Mars. Over consecutive orbits, 3 small glints appeared in a triangular formation. At first, they were written off as cosmic rays striking the camera sensor, but repeated appearances have made that explanation less convincing. Some researchers now argue these could be small probes released by Atlas itself. If that interpretation is correct, then humanity may have already observed fragments of interstellar technology. The critical window for understanding Atlas lies between 19 and the 30th of September 2025. During this period, the object will be moving at 57 kilometers per second relative to Mars. Even a grazing strike at that speed would be catastrophic, vaporizing vast quantities of rock and sending dust into the atmosphere. That dust could drift into the wider solar system, potentially crossing Earth's orbit within a decade. Models show that if any of those fragments contained engineered microbes or self-replicating nanotechnology, contamination could spread beyond Mars. While such scenarios remain speculative, the sheer scale of the potential consequences has prompted governments to begin planning. Emergency planetary defense discussions are reportedly taking place among major spacefaring nations, including NASA, Roscosmos in Russia, China's CNSA, and Japan's JAXA. For the first time, the
The idea of intercepting or even destroying an interstellar object is being seriously considered. Up to now, planetary defense has focused on asteroids and comets that originate within our solar system. An object arriving from interstellar space poses an entirely new set of challenges. Its speed, trajectory, and unknown properties make any kind of deflection attempt extraordinarily complex. Meanwhile, critics of the artificial hypothesis point out that extraordinary claims require extraordinary evidence. Some argue that comets are poorly understood, and that unusual behavior can sometimes appear more deliberate than it really is. They note that the energy required for Atlas to change its speed by 10 kilometers per second is enormous, and no natural sublimation process could achieve it. But others counter that this is precisely what makes Atlas so puzzling. The trajectory changes being observed appear to demand more thrust than a comet could naturally produce. Amateur astronomers have also reported strange phenomena. Images captured over recent months show Atlas's tail splitting into 3 distinct streams, glowing green and pointing towards Mars as if marking a path. These tails pulse and shift like auroras, unlike the steady plumes normally seen in cometary tails. Such reports are difficult to confirm, but they add to the growing catalog of unexplained features. If a collision occurs, Mars may not be the only world affected. A strike of this scale would throw dust into interplanetary space, some of which could eventually reach Earth. That possibility, however remote, is one of the reasons agencies are treating the situation with greater seriousness than their public statements suggest. As the clock ticks down, the question of Atlas's true nature looms larger. Is it a natural object that simply happens to be behaving in unusual ways, or is it a derelict craft, perhaps millions of years old, still running on some form of autopilot? Could it even be an active probe, adjusting its path deliberately to test or observe us? For now, there are no definitive answers. What is clear is that by mid-September, the full attention of the astronomical community will be on Atlas. The Hubble Space Telescope, the James Webb Space Telescope, and the largest ground-based observatories will all be tracking it. Every pulse of gas, every change in speed, and every glint of light will be scrutinized. If the pulses continue, and the trajectory tightens towards Mars, then scientists may be about to witness an impact of a kind not seen in the solar system for billions of years. The official messaging remains calm. NASA continues to release routine updates and images, emphasizing that no confirmed impact is projected. But among researchers, the private conversations carry a different tone. If Atlas does strike Mars, it will not just be a planetary event. It will force humanity to reconsider its place in the universe. When people look up at Mars this September, they may be seeing more than just a reddish dot in the night sky. Above that world, an interstellar object will be threading through space with green streams trailing behind it, adjusting its path with each pulse. Perhaps it is a natural process, extraordinary but explainable. Or perhaps it is something else, the first clear sign that we are not alone. If that is the case, the evidence may not arrive in the form of a radio signal. It may come instead as a comet-like body slamming into a planet, leaving behind a message written in dust and fire. Whatever the truth turns out to be, the coming weeks will be a defining moment in space science. Atlas may prove to be just another comet after all, its mysteries slowly explained by new models and better data. Or it may become the discovery that redefines our understanding of what travels between the stars. Either way, the outcome will shape the next generation of astronomy, planetary defense, and perhaps even humanity's search for company in the universe.